Good morning and welcome to this first session, Managed GitOps in the Cloud, Continuous Delivery with GitOps and OpenShift. We're pretty excited to have you here, and us, that is me. Markus Eisele is my name. I work for Red Hat in EMEA. I'm the developer strategist working with our teams and customers and partners on all things developers. And with me today, thankfully, my partner in crime, Natale. Natale, would you introduce yourself, please?
Sure, Marcus, my pleasure. Hello, everyone. My name is Natale Vinto. I'm a developer advocate here in Red Hat, being part of a team of global developer advocates. And I'm very happy to be with you today, Marcus, to talk about how GitOps can help DevOps and implementing agile processes in modern companies.
Yeah, wonderful. And you know what? Let's jump right into it. So, your journey today will be three steps. You'll understand a little bit about what we're talking. You'll see an extensive and amazing demo in the middle, and we'll feed you with a little bit more information and links and further literature, so you have a fair chance to follow up on everything we've been talking about today. Let me start at the very beginning. So the question is, why are we even talking about this topic? And why are we talking about different ways to develop software? Why are we talking about cloud native development? I think the biggest pressure today is to create value from software, from deployments, from everything we do as an industry. And our ability to create value and the speed with which we can deliver applications is kind of becoming the most important part. We need to make sure that whatever we're creating today with our customers, with our partners, is actually delivering a competitive edge out there. We need to be able to deliver a modern customer experience as an industry. And in order to do this, cloud native has proven to be the most effective way. It delivers the speed necessary by increasing developer productivity. It gives you all the security controls that you ever wished for, starting at the underlying operating system, through the application code, going all the way into your infrastructure. And it can also scale by not only automating things, but also making sure that things are compliant. So we'll take a look into that part a little bit more in detail later. What is the best way to deliver a cloud native application? We've been talking about technology in the past a lot. We've been talking about amazing frameworks like Quarkus, for example. We've been talking about EAP and microprofile. And obviously, we've also talked about OpenShift. These are all the technology bits and pieces. But Red Hat is also about open source and how open source communities come together to create value. And this is about people. And how they work together in a trustful environment, being able to take ideas to production in a trustful environment. And we also talk about processes. And the trifecta of all three kind of is what DevOps is all about. And there's many individual methodologies, processes, bits and pieces to what's commonly referred to as DevOps. But we came a long way. Like, this has not been invented from scratch, right? We started back in the days with iterative software development, trying to create a software factory, inventing continuous integration, inventing continuous deployment. And all this, including what you're going to hear today, is seemingly becoming part of a practice that is called DevOps. And if you add a decent shift left for security into all of this, you might even hear the word DevSecOps when people are talking about all these individual pieces of the bouquet of technologies, processes, and methodologies, how people work together to create modern cloud native applications. So, what is this GitOps thingy? In short, it basically is infrastructure put in code. So let's step it back. As a software developer, you implement your code and you store it in a version control system. And usually something gets it, builds it, tests it, and puts it into production. That is kind of the continuous integration and deployment part of it, right? But this is not really taking into account the target systems, the infrastructure that is ultimately necessary to deploy something like software. So let's assume GitOps talks about treating everything in your application projects as code. And that includes the infrastructure. So Git as the version control system becomes the one central point of truth. And some magic is taking a look at it regularly or when pinged and asked for, and make sure that things are going into the right direction. So kind of a continuous delivery approach for infrastructure operations. A little bit of automation, a lot of automation. A lot of words. And I just want to reiterate, we only have 20 minutes today, so it's going to be a really short flight into a very specific topic. And I already try to outline that there's a bouquet of things that you need to look into. But what is important to understand is whatever we're showing you today is part of OpenShift. So it consists of the build parts, it consists of the pipelines that make all this magic happen. And it also consists of OpenShift GitOps. So you don't really need to look anywhere else. And this is not proprietary, right? This is all software backed and created and curated out of the Cloud Native Foundation. So officially standards that we're using here. So OpenShift is kind of your one-stop shop when looking for a solution platform approach of building modern cloud native applications. And obviously the Red Hat way of delivering cloud native applications starts on the framework level with Quarkus, goes all the way to even more modern approaches like serverless, including what we're going to show you today, and ends up with wiring back your microservices architectures together in a service mesh. And I did not mention the word cloud that much, right? So hybrid cloud is kind of a synonym for you don't have to pick your infrastructure front up, which basically means you can start off on-prem, or you can start off in the left cloud or in the right cloud, or even in the one in the middle. And you can work on all of them. And OpenShift makes sure that you won't have to reinvent the wheel every time, because it's already there. It's there on physical, it's there on virtual environments, it's there on public cloud environments, and even on private cloud environments. So wherever you want to go, OpenShift will come with you. Many words that early in the morning, and I don't even have my coffee here, but I guess now it's time to get the rubber on the road. Natalia, you ready to actually show our guests today what I've been trying to put in so many words?
Yeah, sure, Marcus. No, thanks. It was a really good introduction on the topic. What we wanted to show, because you shown, how to compose a DevOps platform using the Red Hat OpenShift, and we would like to show you with a practical example. We call it the OpenShift GitOps demo. A typical use case where you have your inner loop. In this case, this demo, it's a two-tier application, a front end in Python, a back end in Go, and you edit the code either with your IDE, or you can use Code-Ready Workspaces, for instance, to edit your code in browser. Then you start the CI part. You mentioned it, Marcus. OpenShift pipeline is the engine that create automation and pipelines inside the cluster. Based on the open source project Kubernetes native Tekton, and this created the gold image, the gold artifact, no? And this image, the container image, is typically scanned. You mentioned the DevSecOps. It's important to have the static code analysis, but also to make the security scan. In this case, in the demo, it's Quay.io. And then finally, we have the GitOps part. So OpenShift GitOps is based on the open source project ArgoCD, very popular one in the GitOps landscape. And in this demo, you have basically three repositories: the repository of the microservices and the repository of the configuration, the manifest describing those microservices that you can deploy in multiple environments in OpenShift in the same cluster, or better in multi-cluster. So let's go. Let's have a look at the demo, Marcus. Before going there, I would just want to show that what you say. If you want to install the build part, you can use Operator Hub and install OpenShift build. Then you can install the pipeline. If you want to install GitOps, which is the topic we're talking about today, no, we're implementing a GitOps flow here. You can install OpenShift GitOps at ease from Operator Hub in your cluster, and very nice. This will bring you with an integrated authentication. So the same OpenShift user that access the cluster mapping in. For this demo, we're mapping the developer of this GitHub organization into the cluster. So those developer can access services like the ArgoCD dashboard using the same credentials. So the same group can be Active Directory, LDAP, GitHub in this case, single sign-on. And you have your project here. So for this example, we have a dev environment and a prod environment. Let's have a look at it real quick, so we understand what we're talking about here. So we say that we have the pipeline part. So we have our source code, but then we have our pipeline part. The source code, following along with the demo over here, is mentioned also here. You have a UI in Python and a backend in Go. So you have your source code, and the pipeline is going to start from that source code. Now, we implemented here a CI project just to have it's kind of a CI environment, no? And the pipeline are described over here. So you can either start the pipeline from the OpenShift UI. So starting a pipeline means just filling the data like the Git repository, the manifest repository, some storage if you want to give some storage to the pipeline, and some credential. This pipeline is using GitHub Access, is storing the container image to Quay.io. And just to show you that starting a pipeline is really easy. It can be done manually, but also automatically with a webhook. And most of the cases are in this way. In order to do that, you can do with your favorite IDE, or you can use an in-browser IDE called Code Ready Workspaces. In this case, we have our front-end application. This environment can be opened knowing this access, or if you are working already on the clusters, you can, for instance, you can go to the project represented for the dev environment, and you just click on this little icon over here. You see those are the two backend and front-end deployed. When you click here, this is going to open the Code Ready Workspaces. So it's a workspace containing the source code, and you can start the outer loop from the inner loop. So let's simulate this. We have our environment. So we want to make a change to the front end. Let's install the dependencies in this for this application, and then we just run the application. This environment is also customizable, programmable through a format called dev file. So I'm gonna open the port locally to the environment, and eventually I will have my application up and running locally to this environment. So if you see here, I have my source code and say, ciao, you like cat or dog. Let's say we want to change this string, and we say, hey, instead of ciao, we say hello, and we do this change. So we can review locally our change. That looks good to us. So we add it to the staging area with a commit, triggering GitOps flow, and we will see in a moment what that means. So when you commit your code, you tested locally or in browser IDE. So you are ready to start the process. So you can push it. When you push it and when you configure a webhook for the pipeline, what happens in OpenShift, you're gonna start automatically the pipeline. We can see that if we go to the pipeline list, a new pipeline has been just started from our Git push. If you look here, the pipeline is composed by three main components: fetch the repository, build the container image. That means build the software, the artifact, then build the container, push to a container registry. In this case, it's Quay.io, which can also perform security scan. And if everything is fine, you're going to update the manifest describing that application. So we will see what that means in the while that this goes through. This means that we will see our change. Who's going to deploy our change? Now, ArgoCD is the software implementing the GitOps part. So ArgoCD is checking the source code of the manifest, and through a mechanism, in this case, we're using customized, for instance, to differentiate between the dev environment and the prod environment. So it's the same; those are the same manifest with some slight change in this case. So ArgoCD is gonna monitor this part. When the pipeline is ready, we will see that in action. In the while, let's go to the project representing the dev environment. What ArgoCD will do is deploying the application over here. If we click here, we still see the old string, but when the pipeline finished his job, we can see that our change are here. And again, you can start again the inner loop, or you can monitor your application in ArgoCD. And let me show you also, this is important, the source code of the manifest. So the Kubernetes, this is the repository of GitOps or ArgoCD. We're using here the definition for ArgoCD. If you see, we have this definition that this YAML file can be defined manually, or you can just use the Argo dashboard or the Argo CLI to define your application GitOps controller. As you see here from the source code, we're relying on this repository. We're going into this path. Going into the path means that we're using, in this case, customize. In fact, we are differentiating in this example the environment through branches. So the main is production, the develop is a dev environment. Going into this file, it's just a customization file that will be updated by the pipeline. So the pipeline is gonna update here the new container image hash representing our change. And this is how it's connected the CI word to the CD and anti-CD word with GitOps. So this is basically the flow. We can come back to the the project to see if our settings are already up and running, or if it's taking a little bit more time. Let's have a look quickly. But if you see from the OpenShift web console, everything is integrated. You have the pipeline, you have the project. Now here, say the pipeline just push the container image from the dashboard of ArgoCD. We can refresh the dashboard and check if there's any change. Here we basically use this approach. The dev environment has a sync mechanism that is automatically when you push the code on Git. But if you do any change to the cluster, it's not going to sync automatically. You have to do it manually by clicking over here. And if you want to add, for instance, a new application, it's really easy with ArgoCD. You just add the application from the UI, you put the name, and the source code destination, the path if you're using customized or if you're using Elm. So it's really easy to bootstrap a GitOps application. So when the container image is there up and running, the application will be rolled out. So what we will see now, we should see in the dev environment, is that we have our application up to date. So in fact, if you see, this is our string that we just changed. It's hello, it was ciao. So we can select here if we like more cat or dog, just an example for this application. So that was the dev environment. What about a production environment? The same thing. I'm gonna create an Argo app for prod. In this example, I'm just using a main. I'm differentiating through branches. But here's another thing that you can use when using GitOps controlled application. So you can basically say, okay, in a dev environment, I want the developer to be able to do their change on the class. Like if you remember with Git, as Marcus said, everything is a Git workflow. If you do a change on the cluster, which is not in Git, you may be allowed to do that. But according to ArgoCD and GitOps, you are not following it, the approach. So in fact, ArgoCD here say, hey, this is out of sync. Because our sync policy here was self-healing policy, was not automatic. So if we want to roll back the change, we have to synchronize it manually. But if we come back to the production application, let's say this is the production application, and we do the same stuff like before, we try to do any changes to the application in production, which is not a good thing, as you know, no? Here we have, for instance, in production, we want high availability. So there was, in the manifest, we had 2 replica. Let's say I want to scale it back to 1. Well, as you see, I'm not allowed to do that. ArgoCD will immediately reconciliate what you declared on the cluster, on the Git repository. In fact, here we get back to the 2 replicas as we declared in Git. So how to do our change? Every change need to be done as a Git workflow. So if we want to remove the high availability for our production environment, we have to do that in the GitOps way. GitOps way means we have to modify the manifest describing the application. And let's do it. So we have the chance to also look on how we can do this change. So modifying the manifest means, hey, I don't want 2 replica anymore here. I just want 1 replica. So let's do it the GitOps way. GitOps way means that you're gonna do your change. You're gonna create a kind of feature branch for that, and you're gonna open a pull request where somebody has to review your change and has to approve it. Once is approved, and hopefully is another person, not like me in this example, no, but in a team, somebody's gonna review the change, is gonna approve it and say, hey, looks good to me, and finally can merge it. So this is a Git workflow. Once we merge it, we will see immediately that ArgoCD is gonna detect the change and is gonna going in out of sync, and it will automatically syncing our application. So in a few seconds, we should see our application deployed with the correct number of replicas. And this is what we wanted to have. We wanted a consistent way in Git to deploy application, to describe application in cluster, or even if you think about multi-cluster, this is very useful and very powerful. So that was an example of how to use GitOps for your strategies, and with a real world example with a backend, front end. Of course, there are many strategies that you can follow, but the tool is so powerful that let you do also the control over to it. You can use the Argo webhooks as well. You can use the Argo rollouts. You can use application set for multi-cluster. Also, and I'm closing that, I just wanted to show you that you can even control how you want to deploy an order in the sync. So let's say for product in general, when you deploy your stuff, Kubernetes is not following any order. You're just going in the scheduler is just going in the best at its best convenient. You have the opportunity with ArgoCD to tag deployment, to put for instance an order. So for instance here, you're gonna tag first the backend. You wanna deploy first the backend, then the front end. If you think about databases, we want to deploy first the database. So we're gonna tag it with a sync wave, with a with a smaller number, and then you take benefit of ArgoCD hooks, kind of a pressing hooks where we can run our database migration, maybe with a tool like Flyway, and then we can finally deploy our stuff. So ArgoCD and OpenShift GitOps is also very powerful to have a granular control of the flow. When you use ArgoCD and OpenShift GitOps, it has the mapping with the OpenShift Airback, and thanks to the OpenShift OAuth2 integration. So you have a full control in a single place. You have the full control on many flow, and you can map and you can assign rules and permission in a really granular way for your GitOps workflow. That was it, Marcus. It was that was the demo.
Man, that was pretty impressive. And yes, I do remember that you told me that you can't demo anything in 20 minutes because it's just too short and there's so much to show. I'm absolutely convinced you're doing an amazing job every time, over and over again. So thank you. That was not enough or way too much, and you need to take a second look at many of the other things. So the one last task we have for you today is actually learn more. Stay curious, and the best way is to actually try it out yourself. So there is the developer sandbox, which is literally free, as in free beer. So we do need an email address. You need to register with us, but we promise to not do any harm with it. It's just for us to let you play with the developer sandbox. So just go there. Like whenever there's time, there's a public holiday coming up tomorrow, so maybe that's a good day. In general, the Red Hat Developers Program, just pull out your little smartphone, take a picture of this little QR code, or enter developers.redhat.com. Register. There's articles, there's books, speaking of books, there are a lot of free ebooks. So it's all PDFs you could like literally download and read wherever you're traveling or sitting at home or relaxing. And one book is also there that is very close to our hearts. It's our COVID baby. Literally, we wrote it during the first wave of COVID. And it is about modernizing enterprise Java. So if you're sitting on a heritage of existing Java applications and you're thinking about bringing them into the new world, want to learn everything like with an example and all the management stuff on top, that is your read. Absolutely go get it. We'd be absolutely delighted to also get your feedback. So with that, thank you so much for having spent your time with us today. And enjoy the coming sessions. There are plenty more today, and we hope to see you soon somewhere. Bye-bye.
Thank you. Bye.